Okay, Lance Hancherow is one of the admins for Wild Fermentation Uncensored on Facebook. He is lived and traveled extensively throughout Southeast Asia and is a researcher and author and one of the most knowledgeable fermenters I've seen on the internet. And so I have invited him today to speak to us on history and fermentation techniques and some of how that might overlap with Steve Diver's lecture that we heard earlier, in terms of maybe you'll hear some of the same sort of pathways and specific microbes that actually are employed in both farming and human health.
Okay. Thank you very much. This is really interesting and challenging on the technical end of running this program, but I will probably just get right into fermentation as how we would teach it in ferment classes, and go from there. Probably a little bit about my background is in my family, we fermented things for a lifetime. Growing up in northern Canada for at least the first part of life, being without electricity even. It was a non-electric world for me. I'm just looking at this window that popped up on me. I think I'll have to close that thing. Okay, sorry about the technical end of it here. Okay.
No worries. It's great to have you speak.
Yeah, I was trying to share that folder of pictures I have, and it just doesn't want to do it. Pretty weird. Okay. Strange.
Oh, okay. So again, we have to thank Faiza Coleman Salako, who suggested, he knows the Zoom in and outs, and it's been suggested that we could you could email the folder to me, which would be info@cascadiannaturalfarming.org, and then I could share the pictures for you.
Okay, so what's your email again? It's quite a large amount here. Hello?
info@cascadiannaturalfarming.org.
I'll see if I can bring it up. My goodness, it's a little confusing here on the computer itself. I have a very strange email account too. It only allows you to send so many bits of information.
Lance, have you tried to share the screen?
Yeah, I got it on share screen.
There's one more thing after you do that. After you do the share screen, there's one more click up at the top of the thing. It says something else.
Oh, my goodness. It just comes up with some confusing stuff here. Like it says leave panel, things like that. It's not very
well, I'd say just go forward and maybe just start telling us what you know about maybe some of the oldest ferments in human history.
Okay, we're going to do that. Okay, basically, when you think of fermentation as being a source of food, why would you suppose that humans would even consider eating something that technically is gone rotten. Why would they select that as a means of processing foods? And when you think about it, taste, pleasure, that would be the number one motivation. Does it taste good? Yeah, it's kind of fits into your body's ability to appreciate something. It's nice, so you eat it. Hopefully you eat it and don't die from some reaction of pathogenic bacteria or something like that. And you find that it's quite pleasurable. Another thing is probably of primary importance to us as a food source and a means of processing foods is the fact that a person can detox foods using fermentation. And when you look at the staple foods of humanity, they contain some of the more toxic plants on Earth. Plants are very toxic. Plants can't get up and run away from predators, so they produce toxic reactions, toxic medicines, toxic compounds that resist predators. But by fermenting, we can disassemble the toxins and create foods that can sustain life. And some of the more toxic foods, we can produce a lot of them. And you look at the larger staple food crops of humanity as being very toxic, like soybeans. How about cassava? Cassava fed all of Asia and most of the world where the larger populations in warm countries are. Cassava grows very well, but it'll kill you unless your body is adapted to it over time. But if it's fermented a little bit, it becomes a staple food of your society. If a person's a hunter-gatherer, detoxing a few plants might be important, but you haven't formed a really large civilization of humans yet, because you're missing a key element in producing a civilization at all and actually farming. In fact, you're just going out and foraging. And to do a foraging effort, it takes a lot of energy. Each day, you're going to have to go out individually. And if you're very lucky, the energy you expend is a little less than the amount of food that you can gather. And so you can make it another day, another week, another month. There isn't much time left to store foods, grow foods. You certainly aren't growing them, you're gathering them. And you don't have the extra energy provided by animals that you harness to produce more food in a farming situation. You will find right now, in even looking at hunter-gatherers world over that live like hill tribal people, people in remote areas of the world that are hunter-gatherers, they are as intelligent as anybody else. They work very, very hard, and they never form a civilization. You're in a very small tribal group, and that's quite a different food situation than living in a civilization that supports a lot of humanity. When you have animals to help till the land, like a cow or a horse, something like that, now you can build a civilization around that, because it'll produce enough food that frees some of the people up to develop ideas and technology and building methods and all the things that otherwise would be, their time would be spent just trying to get food to sustain themselves. So that's just a little side note to fermentation. Okay, so we ferment foods to produce, it's a way of processing foods. We have other ways of processing foods, such as cooking, just fire. You can cook foods over fire and then eat them, and they're a little bit more pleasurable sometimes than eating things raw. You can create mixed recipes and things like that. When you ferment foods, now we are finding that they contain things that our body needs, such as probiotic bacteria and enzyme changes, nutrient unlocking and nutrient building in raw foods that otherwise we didn't have. And if you look at fermenting as a very very basic means of processing foods by using what's available in nature, we start to see that nature has very simplistic pathways that we can follow. And just by observing nature, we can select these pathways and produce an end product that we like. We can select a bacterial pathway. We can select a fungal pathway. And we can combine pathways. There's so many options available to us. And just by simple observing of how these pathways work, we can guide a fermented raw product or an unfermented raw product into becoming a food source that we can enjoy. Quite a few people have noticed that of all the foods that everybody is eating, about 60% of the foods that we consider just our normal modern foods exist only because of fermentation. You take things like normal dietary foods of the average American person will include things like coffee and cocoa and that, and you think, is that a fermented food? Yeah, it is a fermented food. Fermentation plays one of the key processes in order to produce things like coffee, in order to produce things like cocoa, chocolate. Very simplistic foods we take as we don't even think about it. Well, they're caused and made by fermentative action. If you go into the older countries that have fermented far longer than we have in European countries or America, for instance, we find that these countries' core foods are all fermented foods. Asian foods, most of the African foods all exist because of fermentation. Basically, what we can do is just let foods rot and eat them, but that's putrefaction because nature is opportunistic. It'll use whatever organism is available in order to do the inevitable breakdown of material things. It'll use bacteria if they're available. It'll use fungi if they are available, and it'll disassemble what they're capable of disassembling. And sometimes such actions are not that good for our humans' health. So we use a little bit of magic, we'll call it. There's magic in nature. And one of the magical components in nature that will take a bacterial fermentation from being a putrefacious rot fermentation over into a good for us fermentation is salt. Such a simple thing as salt. At around a 1% concentration of salt in anything will provide the needed salinity to cause lactic acid forming bacteria to go into action, and it holds back the other bacteria that are not so good for us. The lactic acid bacteria just go crazy when there's salt around, and they reproduce at an amazing speed and produce foods that's safe for humans' consumption. Where if we let a random ferment happen, there's a good chance that we'll produce a lot of bad bacteria that's going to be quite dangerous for us. Just give me a second here on the screen here on this. We seem to have, there we go. I'm back to a better screen situation here. Okay. Let's pull over to a bacterial pathway when we ferment things. These pathways are built of fermentation are built right into I'll call them the core engine of all of nature. They are the little engine that makes life and this material world exist. These microorganisms in nature, which bacteria are a part of, are capable, under the right conditions, to disassemble all material things. They take it apart at molecular levels, and sometimes, due to certain bacterial actions, they put things back together. They unlock nutrients that otherwise are bound up in raw plant material, and they unlock them and make them available. They create enzymatic actions that create vitamins, for instance. Take vitamin C by using certain fermenting actions. We can create vitamin C in many materials. A lot of it is created by fungal actions. There's fungal pathways and there's bacterial pathways built right into nature that we can select which pathway we want to put a raw material on to produce what we want at the other end of the deal. For instance, we could take a tomato, for instance. So just grab a vegetable out of the air, and we could place that tomato into a situation where nature will take it on a fungal pathway, and with the assistance of yeasts, which are a form of fungi, a very specific one, will take the plant sugars or any added sugars we add to it, and we can have a wine made out of an alcoholic drink that we can enjoy. Later on, we can take that alcohol and introduce it to bacteria and produce a vinegar. Using that vinegar, we can put other foods into it and preserve it over a long period of time if we wish. It's up to us. What do? We can harness the bacteria or yeasts and produce an end product that we can enjoy, or we can use to extend the usefulness of the raw material and produce a storage situation that will take us through times when food is not that available to one. There's so many of these. There's a fairly limited amount of basic pathways, and we can mix and match these along the fermentation by using different techniques. Like we can take a material, like I said, along a fungal pathway for a while and then switch it over to a bacterial one, or we can select a fermentation where the bacteria and the yeasts have formed a symbiosis between themselves in nature, and use those cultures to produce combination ferments, I call them. A good combination ferment that many people might be familiar with is the old standby one that's kind of integral with the reemergence of fermentation in the general public in America, and that is kombucha. Kombucha is a combined in symbiotic relationship ferment. It's a combination, combined bacterial and fungal yeast ferment that this relationship, it formed a unique club situation where the yeasts and bacteria involved have formed a handshake agreement between them, and they produce the alcohol and vinegar that they need to survive on. And it produces a nice, pleasurable, and useful beverage for a person. And that's just one example. Many people look at fermented foods as being a storage method for foods, and yes, it can be. A lot of the ferments that are produced in Europe and America are not necessarily suited for long storage, but they are very pleasurable, and they do extend storage in a limited way. A lot of the ferments of the world in older civilizations and older cultures, like in Africa and also in Asia, use a different area of fermentation that isn't used so much in the West, and that is the fungal mold pathway of fermentation. And by using various mold cultures and fungal actions, they're able to convert long storage grains and foods that are high in starches and proteins into fermentable sugars and also the amino acids that we need for health. And those types of ferments are something of interest now in at least the Western world. We're becoming more aware of it and incorporating a lot of fungal action into the foods that we use. And so instead of making acidic pickles endlessly by using the fermentation process, we're able to produce foods like Asian type foods like misos and various things like soy sauces, which are high amino products. These foods can store over a long years of storage, and they're very useful to one's health by using the fungi. It's let's go back to bacterial fermentation. That's one that we like to introduce people to because it's very, very simple. All a person needs is some salty water and dump some vegetables into it and let it sit, and nature takes its course, and you have lactic acid fermented product, a pickle, basically, a slightly sour product that is not rotting, but we can use it for a very high nutrient food that also contains several species of probiotic bacteria. And we know that the probiotics are very, very healthy for us. This is more of a modern concept of probiotics. Go back a few years and you mentioned the word probiotics. Nobody knew what you were talking about in mainstream. Now you mention probiotics and they have an idea that it's something to do with good health. It's been heavily promoted by the industry. And because of the industry advertising, people are aware that they should have probiotics in their diet. And it has created an area where for people that are aware of fermentation and that we're dealing with probiotic species of bacteria and such, then makes the arts and science of fermentation and the fact that we can do this at home using home processing, we can produce very healthy foods for ourselves. So what a lot of people in the Western world here have departed from is growing our own vegetables and you know, doing our own little mini farms in our own backyards. What has happened, I see in America especially, is soil nutrient depletion. And of course, by using fermenting arts, we can remediate the soil and bring it back to its natural state. In nature, soil is built continuously, and it provides the right nutrients that transfer over into the foods we eat. But eating foods that are grown on nutrient depleted soil seems to result in nutrient depleted humans, and we need those nutrients for our own health. And what has happened is the overuse of chemical fertilizers, and that we can see the results of that. Of course, that's what this forum is about, is to produce soils that are highly nutritious, that transfer over to the plants that we eat, and therefore our bodies have the correct building blocks that we can maintain health and also repair any problems we have with our health. The human body needs at least 90 essential nutrients each day in order for our body to have the resources needed to do constant repairs within our bodies and to rebuild any areas of concern. Without those 19 essential nutrients, many syndromes have shown up in the modern world, more so over the last few years. And as soils across America and using so-called modern chemical farming practices in other countries, we see the decline in human health. And it's really important that, at least on an individual basis, that we remediate the soil in our own growing situation, learn how to garden again, learn how to create good nutrition for ourselves. And by harnessing fermentation, we can do that. We can ferment for the soil, and we can ferment for ourselves. We can ferment for our immediate food needs, and we can replenish the soil, even if it's damaged, by reintroducing fermenting methods back into our gardening, if that's as small as one can do individually, or take it up into industrial size farming. I think that the industries are starting to notice that fermenting and probiotics and that are so important, because the buying public is spending money on it. The only concern I have with when industries get involved is sometimes by them taking shortcuts or GMOing certain bacteria and fungi or whatever, and producing something that is not natural. It's departed a little bit from what's already out there in nature. And that could create a problem in the future. I'm not too sure. Time and research will tell us that, but it's I think it's a good idea to stick with nature for the time being. Peter, if you would like to ask some questions, that would be really a good time. Ask some questions, and then we can go along some pathways here.
For sure. 1 second, I'm chewing some bread. So what would you say would be one of the quickest fermentations or easiest fermentations people could do to introduce themselves to that part of food and agriculture?
Okay, a really good ferment that a person can do on a very basic, probably one of the most simplest ferments you could ever do in your life, is just a good old cabbage sauerkraut. It has, if it's properly done, it has good probiotic action. It has good biochemical results in your body, and it's easy to do. And even if that sauerkraut you made just started to get a little bit mushy and not so enjoyable as a food, you just throw it back into the compost pile, and it recycles down really nicely back into the soil structure again. So that's one of them. That's a bacterial ferment. If a person is looking for a personal, very good probiotic source of fermentation, I would recommend real milk kefir. It's the probiotic bacteria in animal milk ferments is very beneficial for human health. Next question.
Okay, so do you know much about the history of the fermenting fungi? Like more, I don't know, maybe start with could you elucidate on Rhizopus specifically?
Okay, I don't know exactly when they would have used it, but it's certainly been used in Asian fermentation for a very long time, more so in China and down into places like Indonesia, with this mold being used to produce foods like tempeh. Different Chinese, Asian-based foods like soy sauces, in a way of dealing with the beans, like soybeans. And by using the Rhizopus mold, is actually doing a conversion on soybeans, and converting unfermentable, very hard to digest starches into something like sugars, carbohydrates that we can use immediately as fuel for our bodies, and also as something that we can ferment along more conventional bacterial and yeast pathways to produce alcohols or soy sauces, or just good foods similar to Japanese misos, that sort of thing. As far as when they started doing that, I have no idea.
Paul Olivier, who follows your talk with closed loop waste transformation, wonders if you have any knowledge of for fermentation for the feeds of poultry and animals.
Okay, well, what we used to do back in the day, back on the farm, yeah, we didn't have electricity, anything. We used to take all of the leftover bits and pieces of vegetables and potato peelings, everything that would normally get thrown out and we wouldn't eat, and we'd toss it in a barrel and it would start to ferment. It would produce sometimes we'd throw in things like grains, and it would make a nice smelly bubbly treat that we used to feed the pigs and chickens with, and they just go nuts over it. And other things like when you milked a cow and you did the milk separations, you ended up with a lot of whey, which is highly quite a protein source. We used to dump some of that in, and when you separated milk, you got this whey, and well, it wasn't that usable as a food source for humans. I suppose we could have used it more so, but you'd feed all the animals that, and they just grew faster. They did really well on it. In fact, animals just go kind of nuts over it. If you've ever raised pigs and you fed them this, we called it just slop, they just go crazy over it. They'd fight each other for it. They knew what was good. And chickens go crazy over it. And they grew faster. They grew healthy. They were strong and healthy. And they certainly grew a lot faster than using some kind of commercial feeds they're using nowadays, unless you put, certain things in the commercial foods nowadays, like, nasty stuff, we'll call it. Then they'll grow fast. Hello?
Oh, so we also have, can the commercial organic foods be trusted?
In my opinion, no. In theory, yes. Organic foods, of course, should be better for us. But I don't know. It just seems to be human nature and a little bit of greed that a lot of organic foods may be in a gray area, let's say.
So on a similar note, we see this with a lot of the commercial farming preparations, that you can never quite get the cell count per like tablespoon or whatever that you would see with your homemade microorganisms versus the fermented food. So it is kind of like the best thing, of course, it seems always, is to just make it yourself. But
I would agree. If you really want true organics, and you take control of your own intake, you take control of your own setup. You can go and buy all the probiotics, buy all the industrial foods you want that claims to be probiotic or organic, and they will never ever match what you can do yourself at in your own situation. A person has to be proactive for your own situation and those you love, those people. We're in an industry, we'll cut corners by nature and by cutting corners, of course, there's a higher profit margin.
well, yeah, okay. So from my understanding, there would basically be no reason ever to like get a probiotic powder supplement, because that's just like basically dead. Who knows how long it's been for years. So I guess, but then do you know much about like, okay, symbiotics, like as in synergy biotics, with like what I've heard is some of the better formulations of modern probiotics are they include the prebiotic instead of just being a substrate that they kind of put dried spores on or whatever.
Yeah, I think that the industry is taking the right tracks, and they're producing better quality products. And the trick is, can you do that at home and do it relatively cheaper? I think that industrial produced probiotics and that do have a place, because a lot of people just don't have the time or the expertise to produce any at home. So at least they're getting a little bit. Anybody that's a little bit knowledgeable, though, you're better off just making your own.
So we're not getting too many questions from the audience. I'm going to ask the audience to also chime in, but here we have another question from Paul Olivier about fermentation getting rid of pesticides and herbicides, if you know much about that. because I can at least chime in that, for instance, vinegar producing bacteria were found to be a main decomposer of glyphosates.
Yes, I was just going to mention that too. Recent research is starting to show that it's opening the door for a lot of research into that area, the detoxing of foods. Remember, I mentioned that's one of the primary reasons for fermenting foods at all for human consumption was detoxing. Now, nature has its own toxins, and we've produced toxins, and our chemically produced toxins are rather hard to deal with. The natural toxins seem to fall apart easier under natural attack, but nature's pretty cagey and resourceful. Somewhere nature will always adapt or produce or already has bacterial and fungal organisms that know how to take apart any chemical formula that we put together. I would say that fungi are going to be part of our saving grace at taking apart materials. Fungi are very, very powerful. And as you said, the acetobacteria appear to have possibilities at tearing apart glycophosphates. So this is an area in the future that I think research and good science development will help us reclaim the earth, remediate the soils. It'll take time, and humanity always needs a monetary impetus to even try anything. And at the moment, the finances for research are not available most of the time. Any researcher that is coming up with these new ideas and that are real heroes, you know, because most of them are working for peanuts and almost survival levels of money to even pursue any good science in that area. They need they're dedicated to what they're doing, and it's going to take a lot of time. If enough money was dumped into the research, we could solve these problems overnight. But it might take another 150 years to really figure things out. Okay.
Okay, so I know this isn't necessarily your specialty, but it's been asked, can you recommend a fermentation recipe to add to the soil?
Myself, no, I can't. What I do on my own soil is I use composting. And another thing that I like to add to the soil is biochar. Biochar to me is it provides an environment where the microorganisms that normally would get washed away from just normal compost every year if there was a flood or anything like that, they are embedded inside of the inside of the biochar. Charcoal in that form has billions of little areas where the good microorganisms can find a home and a safe spot for them, while the rest of them just get washed away every year. And they can come out and they're always left in the soil. It takes maybe around 1,000 years or something for the biochar to break down. And instead of it, their living conditions getting washed away, the bacteria can remain in one spot for a very long time. It's sort of like along the lines of the way in South America, the Aztecs and possibly Incans and whoever else civilizations were there used biochar a lot in their soil structuring. And then the result is we have amazing jungles forming over soil that was biocharred by humans at one time, where if the soil didn't have the biochar in, those areas seem to not do so well, even in nature.
Okay. We have another question from Eve. What is the most potent fermented food that just a small amount of intake daily we as humans can benefit from?
I'd say milk kefir. And another one that's very, very good is any of the Korean kimchis. Now in Korea are about 200 various kinds of kimchi made out of anything you can think of. But their basic, because it was a staple crop, is your Napa cabbage kimchi, the one that most people are familiar, and it would be the #1 fermented kimchi made in Korea as well. That would have the largest crop. And that kimchi also can take long storage conditions and or be eaten basically as a daily food, almost like a salad, a fermented salad. It has enormous potential as containing really large, diverse varieties of good for us bacteria. Another ferment out of Korea that has amazing amounts of probiotic potential is a drink, and it's makgeolli. Sorry, I get this pronounced right. The makgeolli, and it's a slightly alcoholic drink, and it has. I've heard that it has up to, whether you can believe this or not, 50 times the amount of probiotic potential to almost anything else. It's quite an amazing drink, and it's produced using a multi-path fermentation where fungi are involved and bacteria are involved in this fermentation. And it's all combined into an amazing and a really nice tasting drink. I think you're in many parts of Korea, I think the average person would be ingesting about a liter of it a day in their normal diets. And they seem to be quite happy with it.
Okay. Apple cider vinegar is lauded for weight loss. Is there any validity to such claims in your opinion? If so, would the commercial brands with the mother be sufficient?
Oh boy. Well, I'm not a nutritionist. I have my own opinions, and I think a lot of these claims in general are somewhat true, but a lot of weight loss and that hinges on just more than a little bit of apple cider vinegar in a person's diet each day. I think it is a benefit for sure for some people. When you look at things like specific health issues, each person is pretty individual, and apple cider vinegar for one person might work just like magic, where another person doesn't do anything. So you have to approach that on an individual basis, and also with the advice of a person's a person that can monitor a person's level of health by using their methods, test equipment, whatever that you don't have access to. Also, like I said, it's very individual. Try it for yourself, and if it works for you, good. If it doesn't, then it doesn't.
Okay, so do you include animal bones into the mix when producing biochar?
Person could. I think generally, you know, I think it would. You're just producing carbon, and you're trying to produce a carbon that lasts for about 1,000 years in the soil, and just provides a cage where the good for us bacteria and that can hide out while crap's going down around them, you know, floods washing away. It provides them a home. It's sort of like it's not necessarily a prebiotic, but it's an indestructible home that they can survive within by the billions, and be locked into the soil. The carbon becomes part of the soil, and it's heavy enough, and it just sticks in there unless it gets totally washed away. And yeah,
I was just going to direct to the audience that next we have Paul Olivier speaking in half an hour, and he is super knowledgeable about biochar as well as incorporating bone char in to it. You know, or bones into his biochar. But because someone else asked a question about kilns for biochar, I'm going to say we'll ask that question on the next talk, or it'll be explained in the talk. Just to interrupt you for a second. That
oh yeah,
the next expert is internationally recognized, or the next speaker is an internationally recognized expert in biochar specifically. So.
Oh, super.
Yeah, but
because
also.
I'm a huge fan of introducing biochar into things. I think it's necessary.
So in a lot of ways, with both like human health and soil health, it relates to kind of a build it and they will come sort of mentality with the probiotics, I think, where even if you're just scattering charcoal around and you weren't activating it, 3 years later it would become biochar. And similar with the way you can just provide the right conditions for the microbes to bloom, that it is kind of like biochar, even if it's just raw carbon, raw charcoal, is that microbe hotel. And then in a lot of ways, whether it's a homemade magoli in your kitchen, or you're trying to capture microbes from the forest in a few different ways, that these indigenous microorganisms from your kitchen or from the forest, they didn't, you know, they found their way into the forest naturally, right? Like they just were there. Like, I don't know, I just feel like okay, for instance, there was this one study where they looked at the gut microbiomes of African Americans versus Africans that were still in a more traditional hunter-gatherer mode, and there was a lot more fiber in the diets of the hunter-gatherers than the folks who had been part of the slave, like descendants of the slave trade, but then merged with the modern diet. And so I feel it is in a lot of ways like the prebiotics. The prebiotics are just as important as any of the probiotics. Like that, if we're eating an unhealthy diet to begin with, and then we try to add probiotics, it's not going to do anything. Similarly, we need to start from the base with whether soil or our gut, and always be feeding lots of the prebiotics to keep it. So similarly, I guess with biochar, it's like the biochar is a microbe hotel, a substrate, and then the probiotics, then it's kind of like meet and greet, or like all you can eat buffet, where it's like somehow there's this way for the host of us or the soil somehow chooses its partners. Steve talked a little bit about this with the way root exudates are communicated between plants photosynthesizing to then the microbes in the soil food web. And so I don't know, that's just my little like.
Absolutely. You build it and they will come.
Yeah.
Nature already has the organisms out there to remediate whatever we do. Nature really don't care. It has no opinions on us. It's just there. We could throw a nuke into a corner of this world, and to us, that just destroys anything. But in nature already is microorganisms, especially in the fungal realm, that says, thank you, God, you just give me the paradise. I love this. And they just go in there and they start chewing away, and they start chewing things into smaller pieces of nutrient for the next wave of life that moves in. And nature just keeps going in these cycles. It tears things apart, it digests them, and that we call fermentation on a broader sense of the word. And it forms a nutrient for the next wave of life that says, oh, thank you. I need that for my life. And it chews it apart. It rebuilds. Fungi are able to take things apart and rebuild it into usable soil again. So you got all this garbage and toxic mess, and you got fungi that are capable of ripping it apart at molecular levels and re-putting it all back together. And it puts it back together, and you go, hey, what have we got here? And you say, well, that's just garden soil. And the garden plants go, yippee, thank you. And actually, it was a piece of toxic, nasty waste that a few hours before, and the fungi just reconstructs it, and life goes on in cycles over and over and over again. It gets torn apart, it gets eaten, broken down, providing nutrient for the next life form to reconstruct, rebuild, reproduce, and then get torn apart itself, and in endless cycles. And all we do is, for our food sources, is jump in and become synergistic with all of nature, become part of nature. Nature is part of us, we're part of nature, and we have the ability to harness it and guide it. And if we don't harness and guide nature properly, nature will eat us. Guarantee you that. But if we work in synergy with nature, we can work together and we both benefit. If we don't, nature wins, and we're out of the loop. Nature will always take whatever doesn't contribute to that cycle. It just discards it. It's gone. It's chewed apart, eaten as nutrient for something else that'll take its place. Is that a kind of a nasty thought? Or is that a good thought?
Okay. Let's see. What about, is there any date, because we talked about magoli a few times, is there any danger to cultivating the wrong aspergillus, or is there like certain like traditional protocols? Like I've heard, I think maybe it's like by wrapping the rice in a mugwort leaf if you're trying to start a new magoli culture. Have you heard any like ways that you will make sure you don't capture the wrong aspergillus?
I think that's if you're dealing with capturing it wild. Nowadays, a lot of it for your nuruk that you use, you're kind of advised to just buy a nuruk starter. I've made nuruk myself, and I just kind of looked at what species of organisms were in it, and I happened to have various kinds of koji and also various kinds of yeast organisms at my disposal, including the yeast often used in Asia called pichu yeast. So I just kind of just randomly threw that into the mix and made a really nice snurk in northern Saskatchewan in Canada that worked really well. And I didn't worry about the mugwort or any of that stuff. It produced a very nice product. I think it was quite safe. It tasted great. Easy to do.
Okay, so Ray Yoon had mentioned to me that he's heard of that our global environment is so polluted that in places the magoli never is tasting quite the same. And I've heard, I guess, similar stories of like Belgian monks when they tried to industrialize and switch from like oak barrels to stainless steel, that somehow the cultures just didn't produce like the beautiful esters or whatever, and that to really like bring out the fullness of these heirloom cultures is best I don't know, probably not to industrialize and keep it small scale. Do you know much? I mean, it seems like you are very much like into the homemade do it yourself mentality, but you know much about like maybe failures and trying to scale up these fermentation technologies?
Yeah, that's going to be the issue over the next few years as industries become more involved in the probiotic and fermentation movement. The grassroots movement, of which people have been doing for thousands of years, now has attracted the eyes of industry. The eyes of industry is in there for one reason only, and that is a monetary return. And also, when you're dealing with industry, you're going to be dealing with modern materials, like a lot of stainless steel, plastics, and glass even is a modern material. You're not going to be producing it in the old ways of using natural woods and clays and that sort of thing. But boy, that's it's possible that they should do that, but I don't think they will do that. And they're going to we're going to end up with ferments that never existed in the past. In the I was reading in one of the better known ferment research books where the editor scientist that was writing the book explained that over the last 5 years we have developed more in the fermentation world in the last 5 years, new products, new everything, more of what we know about fermentation than we have in the last 5,000 years. And this trend will continue, where each year we're going to double what we know about fermentation and the advances made in new products, everything. Fermentation is a dynamic, ongoing process. Now, whether using modern industrial, faster, quicker, better ways of doing things, GMO'd bacteria, etc., is a good thing. In some ways, I don't think it's a good thing. I think that they should try to incorporate more traditional methods and just upscale it if you want. That's my personal opinion. That's all.
Okay, so like yesterday we were getting pretty deep into it with talking about microplastics but like you said, everything that comes from the earth can also return to the earth, and carbohydrates and hydrocarbons being just different combinations of the same elements. Do you have any specific knowledge of just human detox through probiotics? Like, I'm not necessarily a big fan of fasting, though I know fasting has its benefits, but what do you know necessarily about just probiotics in terms of chelation of heavy metals or whatnot?
Actually, it's not so much probiotics that do a lot of chelation, but it's the what I believe is a lot of the biochemical compounds that are made. Let's take, for example, miso. Until a certain day in 1945, over a couple days, there was a doctor who lived in Nagasaki. Fortunately, they were away from the hospital where him and his crew used to look after the needs of the city. They were also a group of people that advocated using traditional methods. And they were into eating miso and, you know, all the traditional ferments and that sort of thing as being very healthy. But the Japanese people, surprisingly, at that time were very modern, and a lot of people had departed away from those old ways. They're into more modern ways of processing foods and that. And there wasn't so much emphasis on the old traditions. However, a few certainly adhered to the old traditions at that time. And then bang, less than 1 kilometer from the hospital was ground zero. The doctor and his crew walked into streets of horror, knowing that they're walking to their deaths to assist their fellow humans as best they can as people died, and, you know, nuclear radiation had pulsed right through all of them at speeds of light. You know that every cell of your body had been penetrated by radioactive material. And months later, the doctor and his crew looked at their hands, looked at their selves, expecting to see the skin peeling off and cancers and that sort of thing, which didn't happen. And the doctor, being a doctor with scientific background, nearly falling on his knees, thanking the gods for sparing them in their humanitarian efforts, noted in his notes that there may be something in the miso they ate that prevented them from having symptoms of radioactive poisoning. And then, you know, that just sort of got left in his notes. About 1974, 75, somewhere in the mid-70s, a unrelated Japanese researcher looking at soybeans as an agricultural product happened to stumble across the doctor's note, because the doctor had miso, and miso made of soybeans. So he kind of pulled up this old note that he come across and went, oh. He jumped down a rabbit hole that he would never in a million years have jumped down, is the association of the chemicals made during the miso process. And they jumped down that rabbit hole. They found the chemicals that aided in detoxing nuclear materials. And there's names for it. You can run it across it in the book of miso. You'll come across the story in a little bit more detail than I'm talking about. And the doctor and his crew happen to be eating miso all their life. It isn't a magical cure-all, like right away sort of situation. Their bodies were so saturated with this type of biochemical that it provided them a huge degree of protection. So there's an amazing correlation where we can use the biochemicals produced. Now, another person that would know a little bit more about it too is Paul Stamets. And Paul alluded to it, that there was mushrooms, fungi, that he was researching that has protective abilities against things like even toxic attack by what kind of toxins, neurotoxins and stuff like that. And a certain type of mushroom that he'd come across had great potential in that area. So I think in the area of detoxing, I think fungi play a higher level of being able to disassemble and detox thing than anything else.
Well, except at an elemental level. Because
Yes.
at an elemental level, that's when you just get into like phytoaccumulation, bioaccumulation, because you can't break down mercury, for instance, unless of course some of what the there's some research that maybe microbes can literally do cold fusion coming out of France a while ago from this guy Louis Curvan, where he was doing research on basically the calcium content that the eggs were taking out of chickens every day versus what was naturally in their feeds and soil. And he believed that the chickens were able to turn potassium into calcium intracellularly, which is totally fascinating rabbit hole. Like, who knows really how much we really know.
Yeah, exactly.
For the most part, what we do know for what we've seen is that bioaccumulation happens and certain elements never get broken down, you know?
Yeah. The elephants that don't get broken down, if they find an attachment point to another molecule that's passing through, then they just get dragged along and disposed of. So something like mercury could certainly attach to probably some kind of a salt biochemical compound, and then you just get dragged out of the body and disposed of that way, where you can't break mercury down into something else, probably. You know what I mean?
Unless, of course, you're turning it to gold.
Hey, yeah, no, there's something that there's a split controversy over that. Is there a certain type of bacterial action that actually creates gold? Yeah, possibly. We don't know. Not sure.
Well, I mean, that's where we're like venturing into like the realm of plasma physics and alchemy. And so we'll leave that for another time. Right now, we'll just stick with it. But I'm going to ask one last question, and then I'll probably take a break after that until our next talk begins at 8 o'clock.
Sounds good.
But any favorite books?
Any favorite books of mine?
Yes.
That I recommend people get into? Okay, if you're looking at research level books, which are, university type manuals, check out the books that deal with various kinds of ferments. The bacterial fermentation, fungal fermentation, yeast fermentation. There'd be separate books. Solid state fermentation, amino acid fermentation. They also deal with specific ferments like cocoa and coffee fermentations. Other books on the indigenous fermentations of Southeast Asia, South Asia, Africa, etc. And they will deal with specific ferments in that area. Now, books made by other people in the ferment field, I highly recommend any books that are written by the Shockeys, by Kristen Shockey, and also by Sander Katz, of course. Sander has created a situation where he was probably more responsible than anybody else at the resurgence of fermentation at the home use level than anybody else in America. So he deserves our respect, and I really like reading his books. And I think that the average consumer and home fermenter should look at that level of book. The the science level of books are rather expensive. And if you can get a chance to get into them, please do. You might get into through online libraries, etc., like that, or your local university in the bioscience departments will have copies of all of those books. And then I have 3 books just published this year on at Amazon in basic fermentation type books. One has to do with pathways of fermentation. Another one has to do with easy kimchi, just a really good introductory book into the world of kimchi. And the other book has to do with basic sauerkraut and how to do it traditional methods, like crock fermentation into modern ways. And it gives you a good introduction, basics, so that you can take your ferments further than those basic instructions. So 3 of my books, and then all the other ones I stated are real staples.
Well, Lance, I would like to thank you for joining us today. And I would also like to refer people to Wild Fermentation Uncensored on Facebook, where I've seen you upload many, many files. So if you were to go, yes, the Wild Fermentation Uncensored on Facebook, and I'm sure there's other Facebook groups you could recommend that tons of information in the files section specifically.
Oh, for sure, for certain, sure. When you're in the fermentation groups, check out the file sections of each of those groups, because in there's tons of information that gets uploaded.
Well, yes, and once again, I'd like to thank you so much for joining us tonight. And
yeah, I feel like I'm a student. All these everybody in here, like Paul and there's just amazing people. The research you guys are doing, and that I just kind of glossed over a lot of it. I don't bother keeping track of names and publications so much. So first time for me to do this sort of thing. Okay.
But I would say the microbes have definitely made you an ambassador.
Well, we'll try. But we'll try to stay symbiotic with them. Remember that term. Get symbiotic with nature, the environment, and the food you eat, and the soils you grow things in. And if you form that symbiosis, it's a magical area of your spirit, the spirit that exists within all of nature, integrating and forming a happy place for you.
Well, thank you very much.
You're welcome.
And I hope to continue talking with you in the future.
Okay, thank you.